and welcome to my next video, and today we're going to be investigating parallel lines. Now let's jump straight into it. Here I'm going to do 3 questions, and each question is going to be slightly different from the other question, but they're all going to involve parallel lines at some point. So question 1, we have 2 straight lines. I have the line AB and the line PQ. Now, the question is asking us to find the equation of the line PQ. So, parallel lines. Now, just in case you can't remember what parallel lines are, 2 lines are parallel means that they are basically going in the same direction and will never ever touch. Now, for 2 lines to be parallel, it's not enough for both of them to just look parallel. In the question, the examiner has to let you know somehow that the 2 lines are parallel. In my question, if you notice, there are 2 arrows here. These 2 arrows indicate that these 2 lines are indeed parallel. So let's get into it. We want to find the equation of PQ. Now, one major point about parallel lines is that parallel lines have the same exact gradient. So for example, let's say these 2 markers are lines. If the gradient of this line is 4, then the gradient of this line will also be 4 if both lines are indeed parallel. Now they will have the same gradient, but they will have different y-intercepts. So I want to find the equation of the line PQ. So the equation of any line is y is equal to mx plus c. Now, in the previous videos, usually when you want to find the gradient of a line, you need 2 points on the line, and you would use this formula, the gradient formula, y2 minus y1 divided by x2 minus x1. But if you look carefully at this question, PQ, you only have 1 point on the line. So right now it's impossible to find the gradient of the line without another point. We need 2 points usually to find the gradient. However, these 2 lines are parallel because we have the symbol for parallel lines. So if the gradient of this line is -3, then without any calculations, the gradient of this line will also be -3. Yes, it's that simple. All we do is transfer the gradient to the other line. So for the line PQ, we just figured out that the gradient of this line is also -3. Our job now is to find the value of C for the line PQ. To find C, we just need 1 point on the line. And it just so happens, on the line PQ, we have 1 point on the line, point Q. And this is the x coordinate and this is the y coordinate. So all we need to do is substitute the values inside here and calculate for C. So the value of y according to the 1 point on the line PQ is 5. That's this guy here. And we have x. So we're going to replace the x with -1 in brackets plus C. So we just simply have to solve for C. -3 multiplied by -1 is +3. Throw across the +3, we will get -3. So C, well, 5 minus 3 is 2. So we just figured out the value of C for this line. So what's my final answer? Y is equal to -3x, because that's the gradient of this line. And the value of C is 2. This is my final answer for the examiner. I have M and I have the value of C for the line PQ. So once again, parallel lines have the same exact gradient. Now this question was pretty easy. Let's go on to a slightly harder question. We also want to find the equation of PQ, which is this line here. So we have 2 lines, and the examiner indicated that these 2 lines are indeed parallel because we have the 2 arrows, and that's the symbol for parallel lines. So unlike this question, I gave you the gradient of this line straight off, and we just had to transfer the gradient. What's the gradient of this line? if we were to find out the gradient of this line, we just have to transfer its value downstairs because parallel lines have the same gradient. So, what's the gradient of this line? Let me write back the equation here. Remember, I think it was 2 videos ago, I was explaining to you that if you are given the equation of a line, before you can identify your gradient and y-intercept, in other words, your m and c, you first have to make who the subject? Y. So you need to get y on one side and everyone else on the other side. So let's do that first. Draw across the minus 4x, you're going to get positive 4x. Now it's time to draw across the minus 2. The minus 2 is a secret multiply. Draw across this multiply and you will get a divide. Now both items here will get divided by negative 2. So we're going to divide both items here by negative 2. So y is equal to minus 5. Well, 4x divided by 2 is 2x. And a positive divided by negative is a negative. Right? Now, look at it. Y is now the subject and everything else is on the other side. So, now we can identify m and c. But remember, m doesn't necessarily have to come first. Whoever is touching x is your gradient. So my gradient is minus 2. So the gradient of this line is minus 2. These two lines are parallel, so that means the gradient of this line is also minus 2. We are interested in finding the equation of this line. Now, I'm going to have to erase this to make some space to do some more working, so make sure you understood this. So, we just figured out the gradient of the line PQ is minus 2. So, let's write what we have so far about PQ. For the line PQ, we just figured out m is minus 2. We now have to find the value of c. So, to find c, we just need one point on the line that we are trying to find the equation of. And it so happens we have one point on the line. And according to this one point, x is minus 1 and y is minus 3. So we just substitute it inside here. Replace y with minus 3. Replace x with minus 1 in brackets. And we're going to solve for c. Minus 2 multiplied by minus 1 is positive 2. Solve for c. Throw across positive 2. We're going to get negative 2. So c is negative 5. So c is negative 5. We have the value of m, we have the value of c, and it's not good practice to leave a positive touch and a negative. When a positive and a touch, when a positive and a negative touch, you get a negative. This is our final answer for the examiner. That's the equation of the line PQ. Now let's try a slightly harder question. Here we have the 2 points on this line and we are asked to find the equation of LM. Now LM is this line. We know these two lines are parallel because the symbol for parallel lines are placed on both lines. So what's the gradient of this line? Once we figure it out, we just have to transfer it to the other line. Now you notice in the first line I gave you 2 points. It's very easy to find the gradient once you're given 2 points using your gradient formula. So choose 1 point first, call it x1 and y1, and the next point x2 and y2. Let's throw it into the formula. Now you should be a master at this by now. y2 is minus 13. We must put the minus sign. y1 is 8. x2 is 4. Must put your minus sign. It's part of the formula. And x1 is minus 1. So here we end up with minus 13 minus 8. I believe that will give me minus 21 divided by, well, 2 negatives touched. So you will get a positive. So here we will have minus 21 divided by normal 5. Now, excuse me, let's pick up my calculator. calculator, sorry about that. Let's divide these two. Negative 21 divided by 5, and we get minus 4.2, right? So now we have the gradient of this line, LM. Well, technically, because we just found the gradient of this line, and the gradient of this line is minus 4.2. And since these two lines are parallel, that means the gradient of this line is also minus 4.2. So let's find the value of C for the line LM. So we know y is equal to mx plus C. M is minus 4.2. We just have to find C now. To find C, we need 1 point on the line LM. Some people might choose this point or choose this point in order to find C. But we are finding the equation of LM. We have to choose a point on LM. So this is the only point we can choose. Here's X and here's Y. Substitute it in. Y is 2. X is minus 4 plus C. Well, let's do the maths here. Minus 4.2 multiplied by minus 4 will give me positive 16.8 plus C. To solve for C, we throw across the positive, we'll get a negative. So 2 minus 16.8 is minus 14.8 C. Right? Double checking something here. Right. So we know the value of C for this line is minus 14.8. So we erase C now and we have a value for it, minus 14.8. But when a positive touch a negative, you will ultimately get a negative. This is your final answer for the examiner. So these are 3 different questions involving parallel lines. I believe these are the more popular questions. Well, I hope it was helpful. And of course, if you're interested in doing some worksheets to get more practice on these questions, you can visit the website below. And when you go to the website, just click on free maths videos and well, look for this topic, the y equals mx plus c topic. And next to it, you'll see a listing of all the videos. And next to the videos, well, most videos, there will be a worksheet that usually comes with the answer, so you can work towards the answers. All right. So in my next video, I will be handling not parallel lines, but the opposite of parallel lines. Parallel lines are when you're going the same direction. In my next video, I will be handling perpendicular lines. That means the 2 lines will be at 90 degrees to each other. So look out for my next video and well, have a good day.